Okay, everybody. Welcome to our 12th edition of the 13-part series here for exam review for AP Statistics. We are getting towards the end here, obviously, as we close in to exam day. Today is Wednesday, May the 20th. Has anybody checked? Did anybody receive, you can ask me, did anybody receive their e-ticket for the exam yet? Or maybe that'll be coming later this afternoon since it's a 2 p.m. exam. Maybe it'll be 48 hours before. Has anybody seen that in their email? The exam ticket, the e-ticket for AP Statistics? No? Okay. Then we'll check back in tomorrow and make sure you guys got it. I would assume that it's probably sent probably right at automatically 48 hours before your exam. So I would expect you to get that sometime this afternoon or tonight. So if you haven't, please check your email. If you have a problem finding it, make sure you check your other folders in your email. It could have went to spam. And then also you could log into AP Classroom and it should be on there as well as you prepare. So we're going to look at today. The goal today is to look at Unit 6 confidence intervals, and what we're going to do is look at 2 videos and then try to do 2 free response questions. So that's kind of our goal as we move through the process today. So we're gonna watch 2 short videos on one sample confidence interval and then a 2 sample confidence interval, and then we're going to work 2 free response questions that could possibly be on the exam. We're going to skip through the multiple choice part just because this year's exam obviously has no multiple choice questions on there. You are free to answer any of the multiple choice that you want in your packet, but you don't have to, as those are just extra in order to just give you some extra problems to look at. Okay, so we're going to look at the free response here in just a second. Okay, so if you'll look with me, I'm going to share my screen. Before we go to Unit 6 confidence intervals, the first thing I wanted to share with you is I have added a module on the bottom of your course that says Online Review Course and has Stats Medic Unit 1, Stats Medic Unit 2, Stats Medic Unit 3, Unit 4, 5, 6, and 7, and kind of when we finished each of those units. So you can turn those in. I know Alexis was asking about that yesterday, when we could turn that in. And so I have went ahead and added that so you can turn those in. So really, tomorrow is it will be our last session. I am planning to have a session on Friday. That's my plan, to have a recorded or some session that you can watch on Friday, but will only be about a 30-minute brief, just exam tips and just some tips and hints to get you prepared. I do want to share with you a couple more things that were talked about from Stats Medic as well. So yesterday they posted this again. So students, the AP Statistics exam is this Friday at 2 p.m. Eastern, and it is open notes, right? So you have tons and tons of notes from this school year like we do, but you don't want to spend your valuable test time searching through a giant pile of papers. So what they'd recommend is you narrow down your notes to the parts that will get you the most bang for your buck. So they're talking about which ones would be the best. Now, so your skeleton notes from the AP Stats Medic review course, that means the notes from those videos. So from the videos on the AP Stats review course, that's what they call that, the ones that we've gone through. And then there is a sampling distribution review sheet, an inference for proportions review sheet, an inference for means review sheet, and a name that significance test. And then the College Board formulas and tables are already done. Okay, so the College Board formula and tables are done. And then I went through the answers to the 2020 practice AP exam yesterday. And the answers and things are on there. And then you also want to make sure you have your calculator or you're using the calculator online. So I'm going to copy and paste this link into the chat so that you have that. And those are just things that you can have ready when you're taking the exam to give you the best possible chance. Okay, so if you want to, work on that as you go through. Remember, practice uploading your responses using the demo. So if you're going to copy and paste, then I would practice it. Remember, I've got the demo in my YouTube class. So if you go to YouTube as well, and remember, cb.org/AP2020 lets you get to cb.org/AP2020 lets you get to the materials from College Board. But if you look on this playlist, so let me copy and paste this link for you as well. There's another link. So on this playlist, I have all our review sections that we've done, all 11 parts. And then at the bottom, you see I have AP 2020 exam demo. So that was when I walked through the actual AP exam and how you would copy and paste or how you would upload your responses. So you can actually try out that demo by going to cb.org/AP2020, and you can watch my exam demo as well if you want to make sure that you're uploading your things correctly. All right, so with that, let's go to the Stats Medic course. Let's look at one sample confidence intervals. So we're going to do one sample confidence intervals today, two sample confidence intervals. We'll do the 2017 free response question number 2, and then we'll do the Unit 6 practice free response question. So that's our goal to get through today. All right, so one sample confidence intervals is our first video, and here we go.
Hi, I'm Lindsay from the Stats Medic, and this is video 6.1 on one sample confidence intervals. In Unit 5, we already talked through all of our formulas and conditions needed for sampling distributions for one population. So today we're going to be using all of that to help us answer a couple of questions on confidence intervals. So the first example, at a local restaurant, a small order of French fries should weigh 6 ounces. The restaurant owner is concerned that her employees are filling orders of French fries improperly. She would like to estimate the true mean weight of a small order of French fries, so she randomly selects 12 orders throughout the week and weighs them. The weights are given in the table below and all are in ounces. Construct and interpret a 95% confidence interval to estimate the true mean weight of a small order of French fries at this restaurant. So if this question were asked as a free response item, there are quite a few different criteria that you need to hit to get all of your points from the rubric. We like to use the state plan do conclude format. It helps us to make sure that we've check marked all of our boxes. So in the state portion, we're going to begin by defining our parameter. Now, we've been told in the problem that we're dealing with means, so my parameter is a mu. And then I have here that it's the true mean weight of a small order of French fries at this restaurant. Now, it's really important here that you're only referring to the parameter, so the population. If you start talking about the sample, then we're not talking about a parameter anymore. A helpful tip for this is to make sure that you're talking in present tense as opposed to past tense. Also, in the state portion, you need to give your confidence level, and we've been asked to do a 95% confidence level. Now we'll move on to plan, and this is where you have to identify the type of procedure that you're doing, as well as check all of your conditions. So since we are dealing with means, and we only have one sample of data, this is a one sample T interval for mu. Now for my conditions, we're always checking the random condition. We've been told that the owner randomly selects 12 orders, so that's all set. And then for our normal condition, we talked about in Unit 5 how for a sampling distribution of means, in order for it to be normal, there are 3 possible things that you could check. The first is that the population is approximately normal, which we haven't been told here, so we can't use that. Next, I would check the central limit theorem, that n is greater than or equal to 30. And in this case, we only have a sample size of 12, so I can't use that either, which means that we need to show that the sample has no strong skew or outliers. An AP exam tip here is to make sure that you graph your data if it hasn't been given to you already in a graph. You can't just say the sample does not show any strong skew or outliers without actually showing a graph that verifies that. Quick update here. College Board has recently made some changes to the rubrics for free response questions dealing with inference. When sampling without replacement, we must check the 10% condition, which says that the sample size is less than or equal to 10% of the population size. Here is the work you would need to show for this problem. Let's add this third condition to the plan section for the problem. So now that I've hit both of my conditions, I can move on to the do portion. And in the do portion, we're just going to go ahead and actually calculate our interval. Now, I have a formula written here, but you actually don't need it for the AP exam in order to get full points. I like to encourage my students to write it anyways to help you keep your numbers organized and to make sure that you haven't used, for example, a Z instead of a T. So with this one, we're using our statistic plus or minus the margin of error. And my statistic is going to be an X bar. I got this value from my sample data. So in the problem originally, they gave you your 12 data points. It is your responsibility to calculate that mean and then also the standard deviation. So my sample standard deviation was 0.41. And then now I need to make sure that I have a correct T-star. Remember, your T-stars are found from your degrees of freedom. So degrees of freedom are n-1, so in this case, I get degrees of freedom of 11, which gives me this T-star here. Enter everything in, calculate it out, and we get a confidence interval of 6.106 to 6.627. So now we're just left with our conclusion. We are 95% confident that the interval from 6.106 to 6.627 ounces captures the true mean weight of a small order French fries at this restaurant. You'll notice the end of my conclusion matches my parameter exactly. And then additionally, an AP exam tip here, make sure you're always saying confident, not probability. So now let's look at another example using proportions. The City Council is considering changing an old law that prohibits people from mowing their lawns after 9 p.m. In order to determine if the people of the city would support this change, they randomly surveyed 50 people in the city. They find that 23 of the 50 people surveyed would support changing the law. Construct and interpret a 90% confidence interval for the true proportion of people in the city who would support changing the law. So again, we'll go through our entire state plan do conclude format. So in the state portion, I'm going to begin by, again, identifying my parameter. Now this one is for P, the true proportion, as opposed to the mu on the last example. When defining your parameter, if you're ever unsure what to put, an AP exam tip is to usually look at the question, and wherever they've asked you to write a confidence interval, you can usually find your parameter stated right after that. Then we've also identified our confidence level. Be careful if it's ever anything besides 95%. It's really easy to accidentally use the incorrect Z-star or even to leave your calculator in the wrong mode so it does 95% instead of 90. So be really careful when you notice you're not doing a 95% confidence level and instead do 90%. Now we'll move on to the plan portion. So because we're dealing with proportions, now we are doing a one sample Z interval for P. I'm going to check my conditions. I've got random again, also satisfied because they've randomly sampled. Now the normal condition here is different from that of means. We're actually checking large counts. An AP exam tip, make sure when you're doing large counts that you plug in the values and show the number of successes and failures that you get. Now you'll notice here that this is actually n times p hat instead of n times p because we don't know our value for p.
When sampling without replacement, we must check the 10% condition, which says that the sample size is less than or equal to 10% of the population size. Here is the work you would need to show for this problem. Let's add this third condition to the plan section for the problem.
Now we can move on to actually calculating our interval. So my formula that I'm using here is p hat plus or minus a Z star for proportions instead of a T star. And then my standard deviation formula has changed slightly again because I don't know P, I only know p hat. So we're using p hat for our estimate. I've plugged in all of my values and I get an interval of 0.344 to 0.576. Now an AP exam tip, to actually calculate your interval, you do not have to show your work, but if you do show your work, make sure that it matches your answer. And then last, we'll conclude. So we are 90% confident that the interval from 0.344 to 0.576 captures the true proportion of people in the city who would support changing the law.
Okay, so that basically takes care of one proportion and one mean. So what we're going to do is go to the questions on those, and we're going to try to work through. Actually, hold on. So before we go to the questions on those, that takes care of one proportion and one mean. And that was, remember, they did not put the independent condition on there, but then they went back and talked about it. So it did need to be there. So random, independent, and normal. Remember, independent condition is that the sample or that the population is at least 10 times the size of the sample. That would be your independent condition. So now we're going to look at confidence intervals with two samples. So when you have two proportions or when you have two means. And remember, in the do step, you do not have to write out all the formula work. And you would not want to do that on the exam because you really wouldn't have as much time. So it's basically, they use state, plan, do, conclude. We've used panic throughout the semester. Panic would be the parameter of interest, which they've got in the state part, the assumptions, which are your conditions. Then you name the test, and they are naming the test or the interval. Then the interval is basically the do part, but your calculator can just give you the interval, so you don't have to show your work on that. And then C is your conclusion, okay? All right, so let's go ahead and do the two sample confidence intervals.
Hi, I'm Lindsay from the Stats Medic, and this is video 6.2 on two sample confidence intervals. Just like in the last video, we're going to go through a couple examples and we'll break down everything you need for a confidence interval. A pharmaceutical company is testing a new medication for cholesterol. 100 volunteers with high cholesterol are randomly assigned to either take the new medication or the current medication the company sells. After 6 months of use, their cholesterol level will be tested to see if there's a difference in the proportion of people with reduced cholesterol. 39 of the 50 subjects taking the new medication had a reduction in cholesterol. 34 of the 50 subjects taking the current medication had a reduction in cholesterol. Part A, construct and interpret a 95% confidence interval for the true difference in proportions of subjects who had reduced cholesterol after 6 months on their respective medication. And in Part B, does the company have convincing evidence that there is a difference in the proportion of people with reduced cholesterol? So we're going to go through the 4-step process: state, plan, do, and conclude. In the state portion, we need to identify our parameter. So when I identified my parameter, I identified both proportions separately, and then you also need to identify the 95% confidence level. So in the plan portion, I'm going to start by identifying my procedure. Now in this example, I know I'm dealing with proportions because that's been told to me. And then I know that I'm doing a two-sample procedure because they said that they are randomly assigning the people into two groups. So it's slightly different in that we don't actually have two samples, but we do have two groups of subjects. So we're doing a two-sample Z interval for P sub N minus P sub C. It is important that at some point in your solution you identify the order that you're doing your subtraction, so it's nice to get that out of the way right here. Next, we're going to check our conditions. We need the random and normal condition. Now for random, we didn't have random sampling as mentioned, but we did have random assignment. AP exam tip is to make sure you're identifying whether you have a random sample or you have random assignment. Now for the normal condition, we're checking large counts. Make sure that you're checking large counts for both groups. So I have here for my new medication and then for the current medication. Now we can move on to actually calculating our confidence interval. So for my do portion, I have listed out the formula. You don't actually have to do all of that. I like it to keep everything organized because there are so many numbers going in here. You'll notice in our formula here that for the standard error, we're using p hats and not p because we don't know p in this case. Then I've gone ahead and plugged in all of my values and reduced down, and I get a solution of negative 0.073 to positive 0.273. So for my conclusion, we are 95% confident the interval from negative 0.073 to positive 0.273 captures the true difference in proportions of people who have a reduction in cholesterol after 6 months of medication, and that is the new minus the current medication. You'll also notice that I've kept my entire conclusion in present tense to make sure that I'm only talking about my parameter, and then also I've identified my order of subtraction one more time. In part B, we've been asked if the company has convincing evidence that there is a difference in the proportion of people with reduced cholesterol. So when we calculated our interval, we got a negative value to a positive value, and that tells me that it is plausible that there could be no difference because 0 is contained in the interval. So using an alpha level of 0.05, there is not convincing evidence that there is a difference in proportions. An AP exam tip: when you're trying to decide if a confidence interval gives you convincing evidence, make sure you identify the alpha level that you would be using. With this example, we're doing a 95% confidence interval, which tells me that I would have a 5% alpha level for determining if there's convincing evidence. So now let's look at an example with means. There's a rivalry between the AP Calculus students and the AP Statistics students at a large high school. They often argue about which group has the higher average SAT scores. To settle the matter, they take a random sample of 10 students from each course. The sample mean from the AP Calculus group has a mean of 1,320 and a standard deviation of 56, while the AP Statistics group has a mean of 1,352 and a standard deviation of 108. Both population distributions can be assumed to be approximately normal. Construct and interpret a 99% confidence interval for the difference in mean SAT scores between the AP Calc students and the AP Stat students. So we'll go through our 4 steps. The state plan do conclude. In the state portion, we've clearly identified both of our parameters for the mean of the AP Calculus students and then the mean of the AP Statistics students. And this time we're doing a 99% confidence level. In the plan portion, I've noticed, or I've been told, I should say, that we are working with means. So we're going to be doing a T interval. And then I have 2 different samples that I'm working with. I've got the AP Calc students and the AP Stat students. So this is a 2-sample T interval for mu sub C minus mu sub S. Notice again, I've identified my order for the subtraction. And then we'll check our conditions. We've got random and normal. One thing to note here is that the data is coming from 2 independent random samples. That's important. Think about like if one student had been in both groups, that would be a problem. And then for the normal condition, both population distributions have been told to us that they're approximately normal or can be assumed to be normal. So that condition has been met.
Quick update here. College Board has recently made some changes to the rubrics for free response questions dealing with inference. When sampling without replacement, we must check the 10% condition, which says that the sample size is less than or equal to 10% of the population size. Here is the work you would need to show for this problem. Let's add this 3rd condition to the plan section for the problem.
Now for the do portion, so I've listed out my formula here. Now an AP tip for the do portion, many different T-star values are acceptable, but they depend on which degrees of freedom were used. Be sure to show what degrees of freedom you used for your interval. So I've used the precise degrees of freedom that had come from my calculator, so 13.51, and now that gave me a T-star of 2.99 and then this final interval. Now what's important here is no matter which degrees of freedom you use, make sure that your degrees of freedom aligns to your T-star and then that aligns to your final confidence interval. And then we need to do our conclusion. So we are 99% confident that the interval from negative 147.2 to 83.2 captures the true difference in mean SAT scores between the AP Calc and the AP Stat students at this school. One last time, I'm also identifying in here the order of my subtraction.
Okay, so we've gone through that part, and you would also notice in there that the that 0 would be in that interval, so there wouldn't be any difference between the calc and the stat students. We wouldn't be able to say that there was any difference there. All right, so let's look at 2017 free response question number 2, and let's look at the how we would answer it and kind of talk about it just a little bit. So Beginning with this, the manager of a local fast food restaurant is concerned about customers who ask for a water cup when placing an order, but fill the cup with a soft drink from the beverage fountain instead of filling the cup with water. The manager selected a random sample of 80 customers who asked for a water cup when placing an order and found that 23 of those customers filled the cup with a soft drink from the beverage fountain. Construct and interpret a 95% confidence interval for the proportion of all customers who, having asked for a water cup when placing an order, will fill the cup with a soft drink from the beverage fountain. And the key here is that we want to go through anytime they ask you to do a confidence interval, you want to go through these steps. So you see construct and interpret. So P is our parameter of interest. We're interested in the true proportion, and let me stretch this out a little bit for us here, but we're interested in the true proportion of customers who, having asked for a water cup when placing an order, will fill the cup with a soft drink from the beverage fountain. Okay? So that's our parameter of interest. And again, our P hat in this case, our statistic P hat is 23 out of 80, which is, we can go to our calculator, and what do we have for 23 out of 80? That is our sample proportion. I'm pulling up my calculator, but if you have that, let me know. 23 out of 80 is what we're looking for our sample proportion. So 23 divided by 80, thanks you, 0.2875 would now be our sample proportion. So we're able to go back to our problem. And my text disappeared. So, sorry. So the parameter, again, the parameter of interest was the true, let me go back. So the true proportion of customers who, having asked for a water cup when placing an order, will fill the cup with a soft drink from the beverage fountain. And then P hat was 23 out of 80, which was 0.2875. All right, so our assumptions, first of all, random. We look in the problem, and it says the manager selected a random sample of 80 customers. So it is random. So we got our next condition, independent. We assume there are more than 800 customers. And then normal, we say NP is greater than or equal to 10. In this case, that would be 23 is greater than or equal to 10. And then we say N1 minus P is greater than or equal to 10. Well, 80 minus 23 is 57. We would say 57 is also greater than or equal to 10. So it passes all three conditions. So all of our assumptions are met. So now we can name this. This is a one proportion, Z interval. And we can actually get the actual interval at this point, right? So at this point, we have named it, and we can now go and get the interval. So we have P, A, and N. So we want a 95% confidence interval. So I can now share my calculator. And as I share my calculator, I'm going to go to Stat Test, and I'm going to go to one proportion Z interval, and I get 23 out of 80. And my confidence level, I got to make sure it matches. It is 0.95. I'm going to calculate. So I get 0.188 to 0.38668. So 0.18832 to 0.38668. Okay. So as I get that, as I go back, I can now go to the I part. So the interval is 0.18. We said 0.18832. So 0.38668. Oops. And I can now interpret that. So my interpretation of that in part C is that we are 95% confident that the true proportion of customers who, having asked for a water cup when placing an order, will fill the cup with a soft drink from the beverage fountain is between 0.18832 and 0.38668. Okay, or you could say it's contained in the interval. Either way would be fine. Okay, so either one of those would work, and that would be your answer for part A. Okay, let's look at B. The manager estimates that each customer who asks for a water cup but fills it with a soft drink costs the restaurant 25 cents. Suppose that in the month of June, 3,000 customers asked for a water cup when placing an order. Use the confidence interval to give an interval estimate for the cost of the restaurant. All right, so we know that between 0.18832 and 0.38668, we know that that proportion of people will ask for a water cup. Well, we need that out of 3,000. So how many people is that out of 3,000? Well, we can go to our calculator, and we can say 3,000 times 0.18832, and we get 564.96, so about 565. And then we can say 3,000 times 0.38668, and we get 1,160. So between 565 and 1,160 is how many people we're looking at that will get. So between 565 and 1,160 is how many people we're looking at that will get a beverage when they ask for a water cup. Now, each one of these costs the company 25 cents. So if 565 people do that, then that is going to end up costing the company 565 times 0.25, 25 cents a piece. That's $141.25. All the way up to, if 1,160 people do that, that would be $290. So between 141.25 and $290. So the way I would get that is 141.25 all the way to 290. So what we are able to do is we're able to say, using this confidence interval, we can estimate. So we estimate that the manager will lose between $141.25 and $290 in the month of June on customers who order a water cup but fill the cup with a beverage from the fountain, right? So again, we knew between 18 and 38% about would do that, and we wanted to know how much is that out of 3,000. So we multiplied those numbers by 3,000. That meant between 565 and 1,160 customers would do that in the month of June. We know that each customer costs us 25 cents. So 565 times 25 cents is $141.25. 1,160 times 25 cents is $290. So we are basically 95% confident that we're going to lose between $141.25 and $290 in the month of June on these water cups that are being used for beverages. And that is a confidence interval for one proportion. That is an example of that. What questions do you have from this? This is our first free response question. We got one more to go. Okay, if there's no questions, then I'm going to clear this, and we're going to move to question number 2. Okay? We're going to move past the multiple choice. And we get to question number 2. So, question number 2 says, construct and interpret a 95% confidence interval for the mean price paid for coffee in 2005 by all U.S. adults. So let's look at, this is a problem for means. So let's look at this. So we're going to use our, again, we'll be using our calculator. We'll be going through basically the same steps, except we're talking about means. So how much do Americans pay for coffee on average? In a 2015 survey of 105 randomly selected U.S. adults, the respondents were asked what price they paid for their most recent purchase of coffee. The sample data had a mean of $3.42 and a standard deviation of 75 cents. So the parameter of interest is the mean price Americans paid for their most recent purchase of coffee. Okay, and we have a X bar of $3.42, and we have an S of $0.75. Okay, our assumptions, random. First of all, this says 105 randomly selected U.S. adults, so we're good with random. Independent, we are going to assume there are more than 1,050 U.S. adults, which there are. And then normal, we are going to say, in this case, for normal, we can use the central limit theorem, says n is at least 30. And in this case, 105 is greater than or equal to 30, so it passes the normal condition. So now we can go to naming the interval. This is a one sample, and we can say, and again, this is a one sample t interval. Now, why we're going to use a t interval, remember, if you do not know the population standard deviation, you cannot use a z interval. So typically for means, we are going to use t. Whether we're going to use the t interval or t test, depending on what we're doing. Most of the time when you're talking about means, you're going to use t, and that's how it works in the real world as well. Now, here's going to be our interval. So we're going to go to the calculator, and if you go on your calculator, and I'm going to go on mine, but if you'll go on your calculator to stat and over to test, and you're going to go down to t interval, and what you would like to do here is on t interval, you would like to put in the stats. So the x bar is $3.42, and the sx is 0.75. And in this problem, it asks us for a 95% confidence interval. We had 105 as our n, and it asks us for a 95% confidence interval. So we get 3.2749 to 3.5651. So let's say 3.27 to 3.57 if we round to 2 decimal places. Okay, if we round to 2 decimal places, it would be 3.27 to 3.57. Now, that leaves us with, lastly, a conclusion that we have to make. So we are 95% confident that the true mean price paid by U.S. adults for their most recent purchase of coffee is between $3.27 and $3.57. So we have now made a conclusion about this. B says in 2013, tax receipts show that Americans paid an average of $2.98 per coffee. Do the 2015 survey results provide convincing evidence that the average price Americans pay for coffee has changed? And we would say in this problem, we would say yes. In 2015, we are 95% confident that the average price paid is between $3.27 and $3.57 because $2.98 is not in that interval. We have convincing evidence at the 0.05 level that the price of coffee has increased. So we now have convincing evidence, at the 0.05 level, that the price of coffee has actually increased and is now between $3.27 and $3.57. So again, we're looking at, was that $2.98 in our interval or not? If it would have been in our interval, then that means it would have been a plausible value, which means it's possible that, the price of coffee could still be $2.98, the average. Does anybody have a question on this practice free response? So hopefully that cleared up your free response questions for today and your confidence intervals and gave you a nice little review of proportions and means. If you would have had a free response question on two proportions and two means, you would be doing basically the same thing. Remember, you would be having to check your conditions twice, right? You would have to check them for both proportions and for both means. You would also have to, your interval, we would be looking at is 0 in the interval or not, because if we're looking at the difference between two proportions or the difference between two means, then we're looking at is 0 in the interval. If 0 is in the interval, then that means that it's possible that there's no difference. So we cannot say that there's sufficient evidence that there's a difference. And if 0 is not in the interval, then we're able to say, yes, we can say that there is sufficient evidence that there is a difference. So when you have the two proportions or two means, you commonly are looking for if 0 is in your interval or not, okay? And that kind of takes you through everything for Unit 6, confidence intervals in a quick 40-minute lesson. So our goal now, what we're going to do, I'm going to clear this off. Our goal is to go back tomorrow and to jump in to Unit 7, significance test. And we're going to talk about all the types of significance tests, the one sample significance test, two sample significance test, and the difference of means, okay? So there are three types of significance tests here. When we have one sample, when we have two samples, or when we have like matched pairs, or the difference of means. So we are not going to look at chi-square or linear regression. That is Unit 8 and Unit 9. And remember, Unit 8 and Unit 9 are not assessed on the 2020 exam. They only wanted us to go through Units 1 through 7 this year. So those videos we will not look at. So we'll look at videos 1, 2, and 3. We'll look at type 1 and type 2 errors, and then we will go through and answer two questions. So 2015 free response question number 4, and then a Unit 7 practice free response question. So we'll try to go all the way through hypothesis tests and give you an example of a hypothesis test for proportions and a hypothesis test for means. A lot of this should be fresh on your mind because this is something that you just did in the last few weeks. So this should be the easiest part, hopefully, of the review because we've just done it. And that will take us all the way through tomorrow. That'll be Thursday. On Friday, I will have a video for you to watch just on some exam tips from me and some good luck and well wishes for you as you take your exam on Friday at 2 o'clock. But I know you're all going to do really well. So if you will, tune back in tomorrow at 10 a.m. or watch the watch the recording that's posted on our YouTube playlist. Work through some problems. If you have any problems or anything that you feel like is a struggle for you, go back into those units. Remember, AP Classroom is open, and AP Classroom also has a bunch of things on there. So I just want to share that with you. If you go to AP Classroom real quick, you should also, Alexa says she got her e-ticket, so you'll probably also be able to see your e-ticket. But you go to AP Classroom, and let's see if I can get in here. Oh. Hold on one second. Well, one more time. Too many attempts. Okay, so I couldn't get into AP Classroom right then, but if you go, I'll have to go back. But if you go into AP Classroom, you can get into the practice questions as well. So there are some practice questions that they have for the free response part of the exam on there. Okay, and that is posted. There is also if you go to YouTube in the AP Statistics videos, there's a second practice free response exam. If you're interested in looking at that, there's all kinds of materials. So thanks for being here, and I look forward to seeing you guys tomorrow, and we're going to stop the video for today.